Hello everyone, and welcome to another Bytes video. Today we're going to be talking about DP problem LIS. LIS, otherwise known as the longest increasing subsequence, is when you're given an array of numbers and you're trying to find a subsequence that increases as you go. An example to this problem, an answer, could be 0, 1, 7. That's because these numbers are in order from this array and they increase as you go. If this was an example answer, which it is, the answer is 3 because you're trying to get the length of the subsequence array. Now, given this information, how do we figure it out? Well, we're going to use something called dynamic programming, which is a method in computer science that uses memoization. Memoization is a quick trick to save some previous calculations so that when you need to use them later, instead of having to recalculate and add to it, you can just take that answer and add to it. So for example, we're going to have a dynamic programming array that's going to be the exact same size as our array A. At every single one of these locations, we're going to calculate what the LIS is at index I. We'll start off with our index I, 0, 1, 2, 3, 4, and 5. At index I, our longest increasing subsequence is a length of 1 because we only have one number in our subsequence. So if we have an array that's just 4, the answer to the longest increasing subsequence is just 1 because you only have one number there. So you're going to place a 1 in your dynamic programming array. From there, we move on. And now I is 1, which means that you have this array right here. Is this the longest increasing subsequence? No, because 4 and 0 are not increasing. 4 is greater than 0. So that means that nothing's there. Well, given this, what's the longest subsequence you could create? Well, you could create a subsequence of 4 or a subsequence of 0. And both of those lengths are just 1. So you're going to place 1 in your DP array. Now we extend this to 5. And now this is where it gets interesting. What's the longest increasing subsequence here? Well, we finally have a value that's greater than both of these. So that means that we have a longest increasing subsequence of 2. Because you can do 4, 5 as one option, or you can do 0, 5 as another option. And both of those are length 2. So you're going to add 2 to your DP array for index 2. And we're going to continue on. Now we have the value 2. Given this subsequence, what's the longest increasing subsequence of this array? Well, we have 4 to 5, we have 0 to 2, we have 0 to 5, and those are pretty much all our options because nothing else has increasing order. So given that information, we know that the longest increasing subsequence here is 2. Now let's add another value. Let's add 1. What are our options this time? 4, 5, 0, 5, 0, 2, 0, 1. We have another option. But again, that's just length 2. So we're going to add length 2 here. And finally, we're going to finish out our array with 7. What are our options now? Well, we've got some interesting things now because we have 4, 5, and 7 because 7 is greater than 5. So you have a longer increasing subsequence. So that equals a length of 3. So we now know that we can store 3 at that value. Well, there's a few other options we have because we could also do 0, 1, 7, 0, 2, 7, and all of those equal 3. So we know that we're going to store in our DP array the value of 3. Now, this example is pretty easy. Intuitively, you can just kind of check it and build it as you go. But what happens if you had 100 values in array A? Well, you're going to want to write a program for that uses the DP array and something called a recurrence to solve that for you. Well, what's the DP recurrence? That means that for your DP array, every value at I is going to have something stored in it. Well, what's stored in it? We have a couple options. Notice here that if you have a subsequence of just one number, you know that the max length it can be is 1. You also know that if you have 2 numbers, but they're not greater than each other in an increasing way, then you're also just going to have the value 1. So that means that our base case is always going to be 1 because you can't have a string of just one number that has a length of 0. Like you're going to have at least one value. So this is your base case. So we'll call this base case. Okay, so 1. But now we're comparing it to something else. What are we comparing it to? Well, for every single time that we calculated this, we took this index, index 2, and we compared it to everything that was before it. So what if we call this index j, and if this is I, we have to check j for every single value leading up to I. So we know that j is going to be greater than or equal to index 0, and it's going to be less than index I. And so given 5, with this value, we're checking both of these. But what do we check? Well, we check A if the index is less than I, and then we also check if this value is less than 5. How do we do that? Well, we look at the array value, array A. Value at j must be less than the array I. So that means that if our index I equals 2, we are going to have j equal 0 to 2. So that's going to be 0, 1. And we're going to check the value. So a of I equals 5. And a of j is going to equal a of 0 and then a of 1. Now a of 0 equals 4 and a of 1 equals 0. 4 and 0. And so then what we do is we do the second check and we say, is 5 greater than 4 and is 5 greater than 0? The answer is yes. So that means that it's a viable option. And when we have that option, what were we doing before? Well, we were counting the length of what we had at 4 plus 1 because we're adding 5 to it. But we already stored that, remember? That's already what's stored in our DP array. So all we're going to be doing is checking the DP value at j, adding 1 to it because we're increasing it with 5, and we're saving that. So our DP at 4, or at a of j, and we're right here, this value is 1. So it's going to be 1 plus 1 equals 2. And then we have to repeat that again for every single j value. So we're going to repeat it one more time. That's going to be DP of j, j equals 1. That's a 1. It's going to be 1 plus 1 equals 2. And then from there, we want to take the max because we want the longest increasing subsequence, the longest. So we want the max of that. So we're going to take the max for every value of j that's less than I and every value in that array of j that's less than I. We're going to take the max. And how did we get that value? DP of j plus 1. So this is our recurrence, but we're not quite finished yet because notice that we have an option. You can either take the base case or you take the max of the j value. So once again, we're going to take the max of this. So this is now our DP recurrence. Now, how would we be able to solve this problem using just our recurrence? Well, we're pretty much going to walk through it again with j's and i's. And then at the very end, we will be given our answer of longest increasing subsequence of length 3. There's a couple of different variations of this problem. For example, right now, all we're doing is getting the max length of the subsequence. We're not actually getting the values. So at the end of this recurrence, we're going to get the value 3. If the problem asks, what are those values in the subsequence, you're going to have to do something called backtracking, where it saves which values you're using to get your answer. We won't go over that today. We'll do that in a different video, but just keep that in mind to realize what the question is actually asking, because it's not asking for the subsequence. It's asking for the length of it. Now, let's fill this out one more time, and this time use our recurrence. So 4 is our base case. We have no j's that are less than 0. So we're just going to take our base case of 1 versus 0, the max of 1 versus 0, and that's 1. Repeating it again, we're going to hit our base case of 1. For 5, we now have 2 values to go through. Luckily, we just did that. But really quickly, you can see that 4 is less than 5, and the index is less than 5. So you're going to take 1 plus 1. So that's going to be 2. And you're going to compare it in this max value with everything else. So 0 is less than 5. Index is less than 2. So you're going to do 1 plus 1 is 2. Well, luckily, we just have the same value twice. So we take the max of that, which is 2. Continuing on, 2 is 4 less than 2? No. Is 0 less than 2? Yes. So we're going to take this value, add 1 to it, and store it here. Is 5 less than 2? No. So we have our answer. Now we go to 1. Is 4 less than 1? No. Is 0 less than 1? Yes. So we take this value, add 1 to it, and have 2. Is 5 less than 1? No. And is 2 less than 1? No. Our final number, we've got 7. Is 7 greater than 4? Yes, it is. So you're going to do 1 plus 1 is 2. And you're going to compare that for every single j value. So is 0 less than 7? Yes. So that's 1 plus 1. That's 2. Is 5 less than 7? Yes. So it's going to be 2 plus 1 is 3. I'm running out of room here. Then you look at 2. Is 2 less than 7? Yes. So you take 2 plus 1 is 3. And finally, is 1 less than 7? Yes. So that's 2 plus 1 is 3. You take the max of all of these values, which I wrote in such a fun way. You're going to take the max of all those values, and you're going to get the answer of 3. Now, this example is really convenient because your final answer happens to be the last value of your array. But I'm going to ask you something. What happens if you add another index here of 0? Well, that means that the answer to your dynamic programming question is not going to be the last value in your DP array. It's instead going to be the max. Because if we have 0 here, what here is less than 0? Nothing, which means we take the base case and we store 1. Is 1 the longest increasing subsequence of array A? No, the answer is 3. So how do we get that? Well, to get your answer, you're going to have to take the max value from your DP array. So after you do all of this hard work to find out what your DP array values are, you're then going to have to go through it one more time and get the max value of it. And that's 3. I hope this helped. It's a great basic DP problem. A lot of other DP problems build off of this one. So I highly recommend getting to know this one really well. And from there, you can build it for different problems and apply it to a lot of different things. I hope this helped. Thanks for watching.